So I'm just going to quickly go through the program that we are getting underway. And I guess this is a little bit like preaching to the choir, but why do we want to have a program in harvesting looking at automation? Obviously there's a lot of issues around labour shortages, so how can we reduce crew size so that we can get split large crews into small crews and still operate at the same production rate and at competitive cost. Safety, obviously a major driver for all of our innovation programs. How can we reduce workload and make our jobs safer, taking people out of hazardous manual tasks? We were reminded yesterday that we're up to 5 fatalities in this current year. We had 7 fatalities last year, so we're still killing our people in our industry. Yesterday, we heard also a lot about maintaining social licence to operate. So how can we limit some of the negative impacts that we have, some of our operations have on the environment? And of course, reducing our supply chain costs to maintain that competitiveness on an international scale. And of course, what we want to do is continue to mechanise the operations, like keep that graph that Reen just showed, zooming up towards 100%. So how can we take advantage of the fusion of technologies that are happening in other sectors to move into more mechanisation and automation and ultimately robotics? So let's have a look at our current sort of harvest process. A typical New Zealand logging operation converts extracted tree stems into logs, up to about 15 different log sorts, according to the numbers that Reen collects across the industry from our benchmarking project. And while the approach of multiple log sorting is pretty good for maximising log value recovery, it does constrain productivity. It does cost us more, and it's often a bottleneck to our operations, things that are happening on the landing. It also drives construction of really large log landings, which are getting bigger rather than smaller all the time. And we can refer back to work that was done about 30 years ago, and Reen's done a recent project that looked at landing size, and it's definitely bigger than what it was 30 years ago. Current operations only really mechanise part of the operation. We've still got a lot of manual operations happening on our log landings. Log processing on the landing is mechanised, but there's manual elements such as log branding, quality control, log stock taking, log sorting and loading is pretty slow and often requires multiple log loaders. And if you go out to a high production operation these days, it's not uncommon to see three log loaders out there sorting, fleeting, stacking and loading trucks. So there's plenty of opportunity for more developments in automation. So we're looking at a new harvest process. FGR's developed a business case, as Warwick mentioned, for a primary growth partnership, or PGP, which is an alliance between the industry and the government to focus on solutions to these issues that we face. Our business case for PGP funding will cover 40% of the cost of a new program to develop a new forest value chain. The program will be valued at around $29.3 million. It's been approved by the Independent Investment Advisory Panel, and we're currently still in negotiations with MPI to finalise the contract. Once finalised, that new program will provide a large pot of government funding, and we're asking for $11.7 million to leverage the industry investment in this new program. And it'll be over 7 years, taking us out to 2025. So what I'm going to do just over the next few slides is just focus on what the program's about to develop this new forestry value chain, a new harvest process on the landing, as we see here, and also a new robotic log sort yard. So the vision for an automated forestry value chain is no boots on the ground and no hands on the log. So we're really looking at taking all of those manual jobs out of the process. So here you see a concept diagram of a new log sorting facility. It could be supplied by multiple logging crews. It could be supplied from multiple forests. It could really suit a lot of small forests that are being co-located, that are being harvested around the same time. It could be portable, probably not mobile, but certainly relocatable. And at this new facility, you know, we're talking about basically the sort of operation that you see at, say, the Kaingaroa processing yard, except instead of taking full stems, it's sorting mixed grade logs that are being made on the log landing. So moving along, who are we actually working with? We've got a consortium of 9 forestry companies that have joined together from right across the industry. And out of those 9 forestry companies, 5 of them have already indicated an interest in establishing one of these log sort yards. Part of the consortium is 7 manufacturing partners producing 8 new products to be commercialised by 2025. That's the list of the companies. And of course, we couldn't do much without a whole lot of technical or technology development support. So there's a whole list of organisations and people that are helping us to run the programs, to assist the manufacturing partners and to work with the forestry companies. So the plan is split into 3 major projects. The first is really around engineering development for the new automated technology. The second is the human factors, they're all about the people. And the third area is the commercialisation. And I guess this morning we heard quite a bit about the missing link in many R&D projects. As Brent said earlier this morning, you know, there's no point in R&D unless we deploy. He was talking about breeding, I'm talking about engineering developments. It's the same thing. So project 1, the engineering developments, designing, developing new equipment through from alpha prototype design, materials build, beta prototype development. In the human factors project here, we're looking at integrating the operator, sort of two sides to it, integrating the operator into the machine design, but also looking at the impact that the machine design has on the people. So in this area, you know, we've got to focus on that human-machine interaction. You know, what impact is it going to have? What are the new jobs that are going to be created? Some jobs are going to fade away, but there'll be whole lot of new jobs that we can't even think of, I guess. If we think back 30 years ago, who would have thought all the jobs that exist today, such as web design, weren't even created 30 years ago? We also want to develop new training so that, you know, we can roll this out across the industry. Firstly, with the participants in the consortium, but ultimately, you know, this thing should catch on, and there could be up to 50 or 55 of these log sort yards across the country that actually handles the whole of the New Zealand plantation harvest. And of course, recommendations for work skills development and that sort of thing with organisations such as University of Canterbury, Toi Homai, etc., competence. And in the third project area, as Heidi said this morning, you know, speed to market is one of the most important factors in innovation. So, you know, we want to get the equipment out there, get it in the hands of the contractors and their workers, and get it out to market. So that sort of path to market is what this whole project of commercialisation and deployment is all about. So just in the next couple of minutes, I'm just going to flick through, whiz through really quickly some of the landing-based products and then some of the sort yard-based products that this program will develop. In this program, we've got 6 landing-based forestry machinery products that are going to be commercialised, and we forecast just within the program out to 2025 that will generate sales of about $40 million. Some of these projects are things like development of the smart yarder that we saw from Marine, what the Europeans are doing with automation and controlling the hauler system. So it would seek out felled stems, as we saw there with the sensing, extract them to the landing automatically, wait at the landing while it was all safe to land the logs, and then land them, and then automatically go back to the site and seek the next stems to extract. Teleoperated line shifting, as we see here in this diagram, could also be a feature of the hauler control system. Obviously, with the issues around methyl bromide and trying to reduce chemical fumigation, debarking could be an option. We think that there's a real opportunity here to incorporate debarking into the current semi-automation processing log processor that's out there at the moment. So we're looking at a design of a semi-automated processor debarker. Delimbs debark stems to an acceptable standard in the forest to reduce the amount of chemical fumigation that we have to do on export logs, and then obviously makes the log, manufactures cuts to length, etc. While it's manufacturing the log, we need obviously improved accuracy of length and diameter sensing and measurement. So that's one of the projects. We want to eliminate all of that manual QC that's happening out there on the log landings at the moment across the industry. And also, because we've got multiple logs coming from multiple locations to the sort yard, we want individual log ID to eliminate the stock taking that's happening at the moment, another manual task. Eliminate manual log scaling that's happening, and we'll probably see a bit of that tomorrow down at the port. A whole lot of people climbing over logs, scaling them manually. And of course, diverting trucks to go off to weigh bridges so that we can weigh them, and then we have a whole lot of people back at the company in the office converting the weight to cubic metres. So we want to eliminate all of that as well. So logs would be sold on a true cubic volume directly from the processor, rather than on a weight basis at the moment. What about all those piles of what we call waste, which I guess is log making residue, that could end up downstream? Probably less said the better. So we want to, where it's economic, we want to be able to manufacture clean chip. We've already taken the bark off when we made the log, so all the offcuts and everything from the log manufacturing process could make a product that could be sold if it was within economic distance of a chip utilisation plant. So bark off log making offcuts could be fed into a residue management system. If it's not economic, so if it's outside of that working circle, beyond an economic transport distance, then the residues could be chipped and basically just used for landing surface, distributed over the cutover for nutrition for future growth. Looking at the products, I better move a bit quicker. Looking at the products, we want to improve loading. As I said before, loading's taking a lot longer than it should. Some trucks are sitting there for 45 minutes to get loaded. Moving ahead. A quick couple we talked about yesterday. And then on the sort yard, we have 4 products here. The log sorter, a truck loading gantry, load securing system, and again, the log tagging and tag readers. So on in the landing log sort yard, robotic log sort yard, the sorting was relocated from happening as it happens at the moment in the forest on the landing. We relocate it down here to the sort yard. Now this could be a super skid down at the forest gate, or it could be any cocky's paddock, or any piece of space that's available for 6 months to a year until the forest is logged and we move on to another area. Each log loading facility, as I said earlier, could be supported by multiple crews, and also along there you see what we've termed a log loading gantry, or truck loading gantry. Obviously these are just pictures that we've pulled up to sort of demonstrate what these tools could look like, but sorted logs would be fleeted and loaded into a log loading gantry that would then load, HPMV or high productivity motor vehicles in maybe minutes rather than the time that it's taking at the moment. The fact that the logs are debarked will require a much improved log load securing system. Safety is a big factor, not only from the point of view of logs getting lost off the back of trucks, but also all of those musculoskeletal issues that are happening with truck drivers having to throw chains over loads. So we're going to eliminate that manual chain throwing that's happening at the moment. And of course, we need to read all of those tags as they are loaded out of the log sort yard electronically, producing an electronic load docket and eliminating the need for trucks to divert off to a weighbridge. As I said earlier, all logs will be loaded, sold on a true cubic volume, and all producers in the value chain paid on cubic volume, eliminating the current cumbersome manual sort of system of log weighing, conversion factor calculation, JAS scaling, etc., with all its associated problems and errors and etc. So that's really the vision of our new automated forestry value chain. No hand will touch the log, the wood, and no workers will be on the ground. Thanks very much.